Morning, freshmen. So this is just going to be a quick video over the stuff that I want you to work on while I'm out today. So a reminder that we're focusing on what makes up the things around us and what kind of impact do they have on the world. So our objectives today is to be able to define the structure of an atom. So we're thinking protons, neutrons, and electrons. And then last class we modeled with the Bohr models, and now we're going to model with the Lewis dot diagram. So we're going to review through what we did with those Bohr models, then I'm going to teach you how to do the Lewis dot structures, and then I'm going to give you time to work. There are 2 pages that I want you to work on while I'm gone. And then these are going to be what you use to actually build your own periodic table. All right, so if you remember Bohr models, we've got this center here that's showing us that we've got 12 neutrons and 12 protons. I want you to notice the electrons in the rings or the energy levels on the outside there. Okay, so simple way to model an atom is going to have our protons and neutrons in the nucleus and then our electrons around the outside. So again, we'll do an example with phosphorus here. We're noticing our protons, 15 here, and that's going to be our atomic number. And then our 16 neutrons, which we figure out because we have a mass of 31 for phosphorus. So when we take our mass and we subtract our atomic number or our protons, that's going to give us our number of neutrons. So that kind of helps us out with thinking through how do I find my number of protons and my number of neutrons. Again, notice that the bigger number on the table tile, which sometimes is also a decimal, is going to be our protons plus our neutrons because it's our mass. And we want to remember electrons have such a minimal amount of mass that we don't include them in the mass of the element. And then the smaller number is going to be our atomic number, which is our number of protons. Now, of course, remember that protons in a neutral atom are going to dictate how many electrons we have. So to have a neutral atom, we have to have the same number of electrons as we do protons. Okay, so a couple notes on our electrons. Electrons go in the orbitals or shells or energy levels around the nucleus. So we want to notice the first orbital can hold only 2 electrons, and then the extras are going to overflow to the second orbital, which can hold 8, and the extras are going to overflow to the third orbital, which can also hold 8. So we call this the 2-8-8 rule. Okay, so our first shell can hold 2, and then once that's full, it overflows into the second shell. We'll have 8, and then again, once that one's full, we can fill it up again with 8. All right. So those are Bohr models. Now we're talking Lewis dot structures. So each element has electrons that are in the outermost orbital or shell in the Bohr diagram. So some of them have it only in the first shell, and so they might only have 2 or 1 if it's hydrogen, for example. And some of them have an outermost shell that's the second one, and some of them have the outermost shell that's the third one. So that outermost shell is what we represent in our Lewis dot structures. Okay, these are called valence electrons. They're the boss electrons, and we'll write them down in our notebook next week in class. So they're super important. They show us of how an element might react with something else. And so in a Lewis dot structure, we only show the valence electrons. We only show the electrons that are in the outermost shell. Okay, so let's take a look at this. All we're doing is we're doing our Bohr diagram. We're going to look at the outermost shell that has electrons in it, okay, first, second, or third one, and then we count that up, and that's what our Lewis dot diagram is going to be based on, okay? So I'm going to skip that video, but here is an example of our Lewis dot diagram. So hydrogen has 1 proton, so it's a neutral atom, which means that it has 1 electron. So hydrogen, all we do for our Lewis dot structure is we write the symbol that we use for hydrogen, and we put 1 dot. Now I want you to think about Lewis dot structures as if they have a box around them, and on each side of the box you can put up to 2 electrons, okay? So we always fill one side up with 1 electron first, and then we come back around and we fill it in with the second one. So helium has 2 protons, so it's going to have 2 electrons. So we'll have 1, 2 valence electrons, or electrons on that outermost shell, which is the first shell for helium. Lithium now, we filled up our first shell, and now we've got another shell, which is our second one, our outermost one. So notice this one, lithium, has 3 for its number of protons. So it has 3 electrons, but it only has 1 valence electron. Now, why is that? Because lithium has its first shell that's going to be filled with those 2 electrons. Then it's going to go ahead and overflow to the second shell. Now, the second shell is its most outermost shell, and it only has 1 electron. Okay, so we're going to put 1 electron here in our Lewis dot diagram. Okay, beryllium has 4, so same thing, 2 electrons in the innermost shell. Those are going to be filling up, so then we've got now 2 more on the outermost shell, right? 2 plus 2 is going to give me 4 electrons, which is how many beryllium has if it's a neutral atom. Okay, so we only have 2 electrons that are in the valence electrons in the most outermost shell. Okay, now if this is confusing, I don't want you to stress about it, because on your table tiles that you're going to fill out, you can skip if you're confused on the Lewis dot structures until next week. So you can just do your Bohr models and filling out the number of electrons and protons and neutrons first, okay? But if you feel confident with this, feel free to go ahead and move forward with this part. Okay, so I'm going to show you what that looks like on an actual table tile. So here we have boron. And so we're going to write for boron, it has 5 for its atomic number, right? So boron has 5 for its atomic number. I believe that it has 11 for its mass. Okay, so some of you might be seeing that it has decimal points, so it might be 10.94, something like that. So anytime we have a decimal, we're going to round it, right? So if it's 10.9, we're going to round up. If it's 10.1 or 10.4, we would round down, okay? So in this case, we've got boron, so we're going to write boron here. Y'all can totally make fun. I'm drawing with a mouse. Look at me. Not even a mouse. This is a touchpad. Oh, it's amazing. Okay, so I filled out my tile here. Keep consistent with having your atomic number either on top or on bottom. So my atomic number for boron is 5, so that means I have 5 protons. My number of neutrons, I have to do some math, okay? So 11 is going to be my total mass, so that's my protons plus my neutrons. 11 minus 5 is then going to give me 4. No, it's not. 11 minus 5 is going to give me 6, and that's going to be my number of neutrons, okay? Now my electrons, because we're working with neutral atoms, is also going to be 5, okay? So you can fill all those out. You can do the same thing with lithium. Lithium has an atomic number of 3 and a mass of 7 on the periodic table. So I'd go ahead and put that I have 3 protons. I'm going to have 4 neutrons, and I'm going to have 3 electrons, okay? Neon would be having 10 for its atomic number, 20 for its mass, and so then we'd have 10 protons, 10 neutrons, and 10 electrons, okay? Okay, to fill out our Bohr diagram, I just want you, instead of doing dots, I want you to actually write out the number of protons and neutrons. So in boron, we're going to write that we have 5 protons, and we have 6 neutrons. And then we're going to draw out our little electrons here. So it's going to be awesome. So it has 5, right? So there's 1, 2, 3, 4. Woo! Let's do another one over here. 5. Okay? So there's your electrons. Now for the Lewis structure, notice in the outermost shell here I have 1, 2, 3 electrons. So I'm going to do 1, 2, and 3 electrons around my Lewis dot structure. All right, feel free to watch back through this video if you're needing some help with that. And your job today is to get through as much of the table tiles as you can. If you finish them, keep them in your notebook. We're going to be cutting them out and then pasting them onto a periodic table, but I'm going to help you out with that. So don't do that part yet, just fill it out. And if you get done early, then you need to work on your narrative or the particle behavior PFA. All right, guys, get to it and have a fantastic day.